Hello, I'm Mr. Goan, and we're going to be looking at National 5 Maths Relationships Outcome 1.3 today. Now that covers 3 questions involving solving quadratic equations, using the quadratic formula, and using the discriminant to determine the nature of roots. As always, the unit assessments are easier than the questions you would face on the exam as they're testing very specific skills. So we'll jump straight in here, and we're looking at question 10. Solve the equation brackets x minus 6 brackets x plus 10 is equal to 0. Now, as I said, we're using a very specific skill here, so you can see the factorizing's already been done for you for this question. Now, our quadratic here already equals 0, so it's in the correct form. So what we know already is that this first bracket a times this second bracket b is equal to 0, which means that either a is 0, or b is 0, or both a and b are 0. So from that, we can say then that x minus 6 is equal to 0, or x plus 10 is equal to 0. And here we've got two one-step equations. We can add 6 to both sides, giving us that x is equal to 6, or we can take 10 away from both sides, giving us that x is equal to negative 10. Next up is a little bit trickier. Question 11. Solve the equation x squared plus 5x minus 7 equals 0 using the quadratic formula. Now, in an exam, it would very rarely tell you that you would need to use a quadratic formula. You'd have to spot it. But since it's there, we can start off by comparing this to the standard form of a quadratic. ax squared plus bx plus c equals 0. So we know that a is equal to 1, b is equal to 5, and c is equal to negative 7. And the negative is important there, so we need to keep an eye on it. Now, from our formula sheet, we also know that the roots x equals negative b plus or minus the square root of b squared minus 4ac over 2a. It's on the formula sheet, so you don't need to memorize it. We can just pull it straight through from our formulas. Now, we can fill in our numbers since we know what a, b, and c are equal to, which gives us that x equals negative 5 plus or minus the square root of 5 squared minus 4 times 1 times negative 7 all over 2 times 1. So simplifying these, keeping track of our double negative here, is going to give us that x is equal to negative 5 plus the square root of 25 plus 28, which is 53, all over 2. And x is equal to negative 5 minus the square root of 53, all over 2. Now we use our calculator for this, typing that in as carefully as possible using our negative button if your calculator has one. We've got negative 5 plus the square root of 53. I normally press equals here, and then I divide it by the number on the bottom using the answer function. So I get my answer divided by 2, and that gives me 1.140 ... So rounding that to 1 decimal place, 1.1. Now our other root, x equals, and on our calculators we can actually just go back up and change the plus to a minus, and then divide everything by 2, giving us negative 6.140 ... Rounding to 1 decimal place gives us negative 6.1. Those are our two roots. Now you can type that in full, and using a careful use of brackets, you wouldn't have to simplify that to 5 squared minus 4 times 1 times negative 7 yourself. Just be careful with your brackets. Once we have our two roots, we're done, and we can move on. Now the last question, question 12, says to determine the nature of the roots of the equation 3x squared minus 4x plus 6 equals 0 using the discriminant. Once again, it's telling you what to do, and our discriminant we know is b squared minus 4ac, the bit from underneath the square root in the quadratic formula. Now from this, we can also say that a equals 3, that b equals -4, and that c is equal to 6. So filling in our numbers, we get that -4 all squared minus 4 times 3 times 6 is equal to 16 minus 4 times 3 is 12. 12 times 6 is 48. No, it's not. Sorry, it's 72 minus 72. 16 minus 72 is -56. So since b squared minus 4ac is less than 0, 3x squared minus 4x plus 6 equals 0 has no real roots. Having stated that it's got no real roots, we're done. Now, good luck with relationships 1.3